In the last episode, we talked about how the mean for the animal data set was close to 41. But when we looked at the histogram, we saw that more than half of the animals were less than 10 pounds. What to do if that's the case? Well, when we have something that we call an outlier, which is an extreme point that falls outside of the rest of the data set, and when we have what's called skewness, the mean is not the good choice. The better choice is the median. The median means the middle. It means putting the numbers in order from smallest to largest, and then going through, crossing out the last and the first until you get to the middle. Now, we are coders, and we're in data science, so we will not be calculating the median by hand. We'll use a contract. In fact, we'll use the median contract, which takes in a table and a column as a string, and it outputs the median. Now, the data tables that we're also going to use for the median is boxplot and modified boxplot. Let's look at what we're going to do. So we're going to take the median, just like the contract says. It takes in a table, pounds, pounds, and 11.3 is the median, which looks a little more realistic. Now what we're going to do is we're going to create a box plot. We're going to look at the different types of box plots we can do with this and what they mean. So what a box plot does is it breaks down everything into quarters. So the minimum to quartile 1 is 25%. So 25% of our data is between 0.10 and 3.9. And then from quartile 1 to quartile 2, it's another 25%. So 25% of the data is between 3.1 and 11.3. And notice 11.3 is the same as our median. And also, if we look at it as percentile, 11.3 is the percentile. It's the 50th percentile. That means 11.3 is bigger than 50% of the other animals, right? And notice how it's scrunched in, right? So that's what skewness looks like when it's scrunched in. And our tail is here on the right. So it's still right skewed. And we see that because the data is scrunched here, and then we have a long tail on the right. Between 11.3 and 60.4 is another 25%. And then lastly, 172 is the max, and that breaks it up. So all of these are little quarters that we're going to look at. So that's just a regular box plot. Now a modified box plot, right? I just add the word modified and do the same things. It's a little more, I think it's more helpful. And when you guys do your projects, I encourage you to use it. What the modified box plot does is you see these two dots. This tells you that these two are outliers. And from our data set, remember that these two outliers were Cujo and Mr. Peanut Butter. And so it gives us the same information, but as the regular box plot up here. But when we go down here, it talks about a top whisker and a bottom whisker. And that's just the fences for the outliers. So the bottom whisker is 0.1. That means anything less than 0.1 is an outlier. The top whisker is 123. That means anything above 123 is an outlier. In later lessons, we'll learn about the math behind it. But what's nice is in data science, you just need to be able to program a modified box plot. All right. So let's just talk about the three different measures of center. Okay. If you jump right down here, if the data does not have any skewness, no outliers, use the mean. It's the best summary. It takes in all the information. However, if we have an outlier, which remember, an outlier makes a liar out of the mean, or we have some type of skewness, then the better one to use is the median. And lastly, If you have few possible values, like an AP score where you score 1, 2, 3, 4, or 5, then use the mode. That is the better measure of center. Because, right, a 1.5 doesn't exist in this kind of scenario, so it doesn't really make sense if that's the mean, right? Alrighty.